Good morning, my name is Andre Hughley. I'm an Air Quality 2 with Ops 11 at The Ohio State University. This morning I'm going to talk about how to set up a VAV controller, how it works in conjunction with a VAV box and the thermostat. Before you get started on a job, you should also think about your safety considerations, what you may possibly encounter, especially working above a ceiling line. If you suspect that you may have asbestos anywhere near that area, I suggest that you contact your MCL, have him call EHS so that they can come out and do a test of the area. For safety reasons, you should also have with you a pair of safety goggles, a dust mask, because you're above a ceiling line, there's going to be dust up there. As far as tools, you probably will only wind up needing, say, a squeeze bulb kit, a 6-way. This could be used because you may have to take the cover off the box where the controller is located. So you would need some sort of tool to take the screws out. I like personally to use an angle cutter to get the air lines off if I have to clip them to make them fit. Or, as you know, sometimes the very end of it, it'll get widen out and won't stick tight on the controller. You'll also need at least 2 gauges. That way you can see your pressure readings while you're working. Now that we have been through this here, we're going to get started with adjusting a VAV controller. This here is called a variable air volume box. This is the damper actuator. This shaft here is linked to the damper inside the box. This is called a VAV controller, and it works in conjunction with the thermostat to control the damper actuator. That way we can control the airflow that's going into the room or the space we're trying to heat or cool. At this point, we're going to talk a little bit about the controller. This is a KMC volume reset controller. One of the things I find helpful with these type of controllers, they're not position sensitive. We can set this horizontal, vertically. I've set them where you can turn them upside down. They still work good. You will find that on this controller, one of the special things about it, you have a wheel here that you can set by your damper action. If your damper is normally open or normally closed, you can loosen up this screw, you can turn this wheel and set it to the position you need. We have a port for main air, a port for the branch line, which will go to the actuator. We have our air ports that reads the velocity of the air entering the box. This will be the high side port. This will be the low side port, which will read the air as it actually exits the box. This will be a port from our thermostat that will send a pneumatic signal that tells this controller how to work, what you want it to do. One of the things you need to be aware of before you actually get started with installing a VAV controller is you need to determine the position of your damper, whether it's a normally open or normally closed damper. In making the determination that this damper is a normally closed damper, we look at it. Our actuator doesn't have any pressure on it. Once it pulled back, it closed the damper. That told me that this was a normally closed damper right here. If this was a normally open damper, what we would then do is on the controller, you have a small dial. Loosen the screw, then turn the dial indicator to normally open. But as I said, this is a normally closed damper, so this dial will be at the normally closed position. Normally, when we're installing a VAV controller, we're working above the ceiling line on a ladder, putting these in. For today's purpose, everything's down at ground level, makes it easier to see. When you're going to work on these here, one of the things you want to find out first is which line is your main air line. This here would be our main air line. This will go into the main air line port. This will be our thermostatic air line, pressure coming from the thermostat. This will go into the port labeled T. As you can see here, at this point, I do have a gauge on the thermostatic line. That way I can see what pressure is coming from the thermostat when we go to adjust the high and low settings. Then your velocity air lines. The green line goes to the low side, labeled L. Our high side will go to the port labeled H. This here measures the amount of air that's entering the box before the damper and the amount of air that's going out of the box past the damper. There will be a pressure drop which will help make this here work. We will also have a line coming from the B port, our branch, and that will go to the, in this case, an actuator. We're now going to show how to make an adjustment on the low thermostat side. We have a thermostat gauge here. There's times when you can have a gauge, put a gauge in the line above the ceiling so that you can watch that. And we'll have a gauge going from the in between the controller and the damper actuator so that we'll know how much pressure we're actually sending to it. One thing to keep in mind in making these adjustments, because it is pneumatics, it's slow. Typically you may only turn the knob maybe a quarter of a turn, and you may have to wait 25-30 seconds to actually see an indication on the gauge. I like watching the gauges because this shaft can move ever so slightly and you can miss it. That's why, to me, having a gauge in between the branch line is important. At this time, we're actually asking for heat, but we want to have minimum airflow go through past the damper, exit out on this end across the coil into the space. I'm going to adjust our low side stat, which is this knob. It has an arrow on it telling you which way to turn it to increase pressure. If you want to decrease the pressure, you just turn it in the opposite direction. So by watching this gauge, our branch gauge, we'll now see if we're sending air to our actuator. Okay, you need to also be aware, one of the things you want to keep track of is your spring range on your actuators. For this actuator, our spring range is from 8 to 13 psi. So I'm trying to set my minimum at roughly 9 psi to get this actuator to open and just crack open the damper to allow airflow. If you look at the gauge, you'll see that we have 8 pounds of air pressure. Our actuator has started to move. You can tell by, you can see the shaft here. As this extends out, this will move the shaft to the damper. Our damper is going from completely closed, which you can tell by the groove on the end of the shaft, that the damper is now slightly open. What we'll do is we'll see if this stabilizes, and we're now at about 9 pounds of pressure, and that's what we're going to use for our minimum on the damper. And that will be controlled by the thermostat, which is currently reading 0 pounds of pressure. This thermostat in particular is a direct acting thermostat. What it's actually doing is calling for heat. So with 0 pounds of pressure here coming to the controller, we really want minimum airflow to pass through our box. Typically you would have a valve on our reheat coil. That valve would go open at 0 pounds of pressure. But our main issue, what we want here is, instead of having 350 CFMs blow through here, we might only want 250 CFMs to blow across that coil so that we're picking up the heat off the coil. Once you get your your minimum side pressure set with your controller, you then want to do your high stat side. As you can see, we have no pressure on the thermostat line. I'm going to adjust our thermostat for cooling. We should get pressure here. Then we'll make an adjustment with this knob for the high stat side to control the damper. So with our thermostat set for cooling, we're asking for high thermostat pressure. As you can see, our gauge now is reading 16 pounds of pressure. We're now going to adjust our controller for the high side, which will open our damper and increase the amount of CFMs that will be exiting from this end into the space we're trying to cool. As you can now see, we have roughly 16 pounds of air pressure, thermostatic pressure coming from the thermostat. That is telling our controller that we want this damper to go open wider for most purposes cooling. We're trying to get as much cool air into the room as possible. So we will then make an adjustment on the high side of the controller. We should get an indication on the gauge of the pressure going to the actuator, telling the damper to move the damper open. And one thing to keep in mind, this is a slow process. It doesn't happen boom. One of the best things of working with digital controls or building automation, things happen a lot faster than they do with pneumatics. If there's confusion on the part of the damper, what we're really trying to do here is control the amount of airflow. For heating purposes, you don't want as much airflow into the space as you get for cooling. As I said, if you have too much air, that will then send too much air across the coil, so we won't actually pick up the heat. For cooling purposes, we want to push as much cool air into the room as possible. So in that case, we may take the damper wide open. We will want at least 13 pounds of air pressure to this, telling this to go open for cooling purposes. There's times when you could use your squeeze bulb to replace your thermostatic pressure. Just disconnect your thermostatic line, put your squeeze bulb on it, apply pressure, and that will simulate your thermostat calling for cooling. Hopefully you guys will enjoy this video. Hopefully you will have a better understanding of a VAV controller, how to set it up. If you have any questions, please feel free to call.